What's up, Tech Titans? Welcome back to All About AI Tech, your one-stop shop for all things artificial intelligence. Today, we're tackling something truly epic, something that could rewrite everything we think we know about reality. We're talking about Google's recent announcement regarding their Willow quantum chip. They're claiming it's not just faster than anything we have available now. It's so fast, it might actually be borrowing computing power from other universes. Now, I know what you're thinking. That sounds crazy, right? And believe me, a huge portion of the science community is thinking the same, but the implications are huge. So let's dive into the data, dissect the claims, and see if Google's latest breakthrough is a revolutionary. Get ready, because this is going to be a wild ride. Show montage of futuristic cityscapes, quantum entanglement visualizations, and clips of scientists discussing the multiverse. First, let's talk about Willow's performance. According to Google, and this is a big according to, they've created a chip that solved a complex computational problem in a mere 5 minutes. 5 minutes. Now, a normal supercomputer, a beast of a machine by any reasonable metric, would take an estimated 10 septillion years to do the same thing. 10 septillion. That's a 1 followed by 25 zeros. That's longer than the age of the universe. That's about how long it would take you to count to that number. It would take you millions of years. So, incredibly impressive. But does the achievement mean that Google just proved the existence of parallel universes? Show animated graphics showing the scale of 10 septillion years compared to the age of the universe. Show images of supercomputers and Google's Willow chip. This is where things get deliciously mind-bending. Hartmut Neven, the brains behind Google's quantum AI lab, suggests that Willow's incredible speed might be explained by the many-worlds interpretation of quantum mechanics. This is a theory that suggests that every quantum event, every tiny little decision that happens at the tiniest possible level of reality actually creates a new, branching universe. So, if you follow this line of logic, the computations Willow's performing aren't just happening here. They're happening across countless parallel universes simultaneously. The idea is mind-blowing, and some experts are lining up to shout hallelujah. They're saying the results align with the theory and even support a multiverse. Show visuals of branching timelines, depicting the many-worlds interpretation. Show images and quotes from Hartmut Neven and David Deutsch. But here's the thing. Not everyone is buying Google's out there theory. Many distinguished physicists are strongly pushing back, citing a bunch of issues. One big piece of skepticism centers around the task itself, random circuit sampling. The experts are saying it's not some useful real-world calculation that's been tackled at an unprecedented speed, but a problem designed to show off quantum technology. Think of it like this. It's impressive if a quantum computer can solve a difficult, complicated arithmetic challenge faster than a normal supercomputer, but only if that same complicated arithmetic problem could also have some practical application for things like weather forecasting or drug discovery. The skeptics aren't saying that Google's success is not significant, but they are saying it is fundamentally misrepresented in both the press releases and Neven's own comments. Show visuals of scientists critiquing Google's claims. Show quotes and graphics illustrating concerns about the random circuit sampling benchmark. Before we dig deeper, let's briefly touch on quantum mechanics. It's a bit tricky, but the core idea is that at the subatomic level, things operate differently than we anticipate from their behavior in the everyday world. Quantum particles can exist in superposition, meaning they can be in multiple states at once. This is often related to the term Schrödinger's cat. These states get linked through entanglement, where particles influence the other's state even when physically separated. Quantum computing makes use of these spooky mechanics to make exceptionally high-speed calculations, but the inherent weirdness of quantum mechanics is precisely why many experts are uncomfortable with Google's grand conclusion. These kinds of calculations shouldn't be happening across other universes, but it might be useful that Google's results reflect those many-worlds possibilities. The skeptics seem to be suggesting the most accurate description is quantum mechanics, not the many-worlds interpretation. Show animated graphics explaining superposition, entanglement, and the basics of quantum computing. Show images of quantum particles and their behavior. So, if it's not parallel universes, what else could explain Willow's incredible speed? Well, there are other interpretations of quantum mechanics that don't involve a multiverse. For example, the Copenhagen interpretation suggests that quantum systems exist in a state of multiple possibilities until a measurement occurs, at which point the system collapses into one definite state. This interpretation neatly avoids the need for parallel universes to explain quantum calculations. It's not saying it's impossible that other universes exist, but it's saying it's certainly not necessary to explain how quantum AI is working with Willow. There are other ways to interpret what is happening. And frankly, some experts are saying that Google has just fallen head over heels in love with their own marketing spiel. They suggest that Google was trying to hype up a technical achievement, but that the multiverse theory may be more of a marketing tactic than the factual result. Show graphics explaining the Copenhagen interpretation and other alternative explanations of quantum mechanics. Even if we set aside the multiverse debate, Willow's computational power remains pretty darn amazing. Imagine what a quantum computer of this speed could unlock. We're talking about revolutionary advances in AI, where the power to train models is exponentially increased, potentially resulting in superintelligent machines within the next 5 years. Cryptography could be entirely transformed, but this comes with associated risks. If algorithms like these can be designed to encrypt communication, they can also be used to decrypt those same methods. Drug discovery and materials science stand to benefit enormously. We're talking about designing and testing an infinite number of new molecules, materials, and possible drugs. Show visuals of potential applications of quantum computing in AI, cryptography, drug discovery, and materials science. Okay, so Google might have gotten a little carried away with its multiverse claims, but let's not overlook the huge achievement with Willow. This chip demonstrates remarkable progress in controlling and scaling quantum systems, including the capability to fix errors at an exponential rate as it incorporates more qubits. It's a truly major step toward building the super-powerful quantum computers we've been dreaming about, ones that could tackle problems currently far beyond the capacity of even the most powerful supercomputers. The question now is when, not if, quantum computing will become commercially viable. Google's work is still in the research and development stages, and the full capabilities and challenges of quantum computing are still largely unknown. Nonetheless, Willow's breakthrough presents a compelling vision of a future where quantum technology transforms multiple industries. Show images of Google's quantum AI lab and scientists working on quantum computers. Show graphics illustrating the roadmap for future quantum computing development. So, did Google just prove the multiverse is real? Probably not. But Google has made a phenomenal advance in the technical capabilities of quantum systems. The controversy surrounding Willow's performance highlights the boundary between extraordinary technical achievement and still largely unknown, or perhaps unknowable, scientific questions. The ongoing research will provide more valuable insights into both the power and limits of the technologies. However, regardless of whether we ultimately decide we live in a multiverse or that Google just jumped the gun with its latest press release, the implications of faster, more reliable quantum computing are absolutely mind-altering, and that's something we should all be paying attention to. What do you think? Let me know in the comments. Don't forget to like and subscribe to All About AI Tech for more mind-blowing explorations of the world of artificial intelligence. Show in screen with social media links and call to action to subscribe.